Hello everybody, my name is Steve Adler and I want to explain the concept of a feedback loop. I've been posting stuff on uh, the water cooling subreddit on my first build of what I call the Franken loop. And in doing so, I've done a lot of tinkering around, and I sort of fell into this. I sort of discovered this feedback loop, which is kind of a neat concept that I wanted to share with the water cooling community. When I first started building my first configuration, my first loop, it was a standard sort of water blocks in parallel. I've got the CPU and two GPUs. My radiator was a 360, and I was getting really good flow rates, 450 liters per hour through the outer loop. I didn't have any way of measuring the flow on the inside of the loops, on the inner branches of the parallel loops, but I assumed it was 1/3 of this flow rate, so I was getting about 150 liters per hour. And I was very satisfied with the performance, except the radiator. I mean, sort of the cooling performance, the heat exchange that was going on at the water block, but the radiator was not dissipating the heat well enough. So I went off and I got a MORAD radiator. Doing so decreased the flow, and in doing so decreased it because the radiator has a very large internal resistance, and so the flow at the water blocks went down, I would assume, by the same factor. So 190 divided by 3, so roughly 63 liters per hour. And I didn't particularly like that. I wanted to get the flow back. So what I did is I started throwing pumps at my loop, and I decided I sort of settled on putting pumps in parallel. I mean, a lot of people do pumps in serial. I'm not going to go into the wheres or whys of why. I mean, I did it. It worked kind of, but I like the idea of, just because it's kind of funky, to do pumps in parallel. So I did, and I started messing around with the pumps. One of the things that I wanted to do was run each one of the water flow through the water blocks of each one of these segments independently. And as I was playing around with revving up each one of the pumps, I realized that you really can't do that. They're all essentially coupled together. And in one of the situations that I ran into is if I ran two of the pumps at full capacity at 100%, and the other one I just left idle, the water flow through this water block that I left idle would actually go in the wrong direction. It went backwards. And I could see that. I didn't have flow meters to tell, but I could see that because I had a plexi cover on my water block, and I could see the water flowing backwards. The other thing I could see is that the water was flowing faster than if it was in this condition. So when I was running the pumps in this situation, I thought I was going to get a lot more flow. I didn't, mostly because each one of these pumps is essentially fighting. They're all fighting each other to get the water out. And so there's a huge amount of pressure that's being built up by these pumps all pumping sort of in the same direction. So you're not really, it's like a bunch, I don't know, you're not really increasing the flow. And you could see by looking at through the plexi that the bubbles were, filling up inside the water block. I had a really hard time trying to bleed the water block by trying to get the bubbles out because the flow was so low and so on. So, but then when I did this crazy thing and just ran two pumps and left the other one idle, all of a sudden you could see that the flow was much faster, and in one water block, the flow was going backwards. So what was going on is I set up inadvertently a feedback loop inside my parallel loop configuration here. So I thought that was kind of cool, and one thing I did is I thought, well, if I was getting that, why not run this third pump backwards? And I did. I changed the input and the output, and ran the pump, essentially forcing the water to go backwards into the loop. And the system worked really well. I had this one inverted pump, two pumps pumping in the forward direction, one pump running full blast in the backward direction, I was getting much higher flow rates, and I wasn't building up any kind of internal heat loops as because of this external pump and the pressure that was building up across the parallel portion of the loop. Cold water was actually flushing in, distributing properly through the water blocks, and the heat was actually, the hot water was actually coming out. And all my temperature benchmarks showed that the system was actually running quite well. And so I thought that was kind of cool. Anyway, so I decided to go sort of all out with this feedback loop thing, and I put a feedback loop on each one of my pumps, as you see in this configuration here. And what this did was a very cool so I think is a cool outcome of this is that by putting in these feedback loops, one, you increase the water flow, right, on the water blocks, and two, you decouple the pressure action that between the pumps. So you can run these pumps completely independent from each other. You can rev them up or run them idle, and the water flows fine. So in this case, if I run these two guys at full and leave this one at idle, it's not like this guy suddenly starts going backwards, or like, in this situation. It just sits idle. I mean, there is some water flowing in this water loop, but it's sort of at its own rate. And each water loop essentially runs this feedback loops. They all run at their own independent rate. So effectively, what you've done is you've decoupled the pumps, and it's kind of like having three independent loops that share a radiator, which is kind of a neat feature. So if you look at the flow rates I was getting, at this point on this final configuration, I actually bought more, what's it called, the flow meters, and I put a flow meter at the output of each one of these pumps so I can measure the flow. And I was getting 218 liters per hour through the GPUs in this feedback loop configuration, as compared to the total sort of overall flow through the radiator of 202 liters per hour. So, and if I turn off this feedback loop mechanism, then what happens is kind of interesting. The flow on this outer loop goes up to 280 liters per hour, and on the inside, I'm only getting 75 liters per hour. So you can see, you get much lower flow rates, right? Although what happens is, it turns out that 75 liters per hour is actually plenty flow to make these GPUs, for the heat exchange of these GPUs. So when I first ran this with the MOAD radiator and without the pumps, this was much less, the 75. I guess it was probably around 50 or 60 or something. And I started to see sort of the heat exchange loss. But going up to 75, apparently that was fine. So 218 is essentially overkill for the heat exchange issue, but it does give you this feedback loop, this completely independent operation of these pumps, which I think is a nice feature. This is the water distribution panel of my Franken loop, and what you can see here is this is the feedback hose. I've got a bunch of ball valves to be able to turn on and off this feedback loop. And that's how I did that test of looking at the various flow rates with and without the feedback loop. I also have ball valves on each one of the segments, so I can actually turn on and off a whole segment if I needed to. And that's necessary when you fill this loop. It's a very complicated loop to fill. And you get air bubbles in and so on. So you have to essentially fill each loop independently, and so that's one of the, I guess, downsides of having all this, having a parallel system with this feedback loops and so on. There's a final system with all the LED lights running. And finally, what I have is a temperature benchmark. I ran Time Spy Extreme stress test. And this basically shows that with or without the loop. So on the left-hand side, I ran the benchmark with with the loop turned off, the feedback loop turned off, and then I went and I opened up the ball valves, and then I let the feedback loops run. And this is running the test with the loops on. And as you can see, there's essentially no difference in the heat exchange. So what we're seeing here in yellow and in sort of blue or light blue, whatever this color is here, these are the temperatures of the GPUs. So one of the GPUs is running, it's hard to see, but it's running at 40 degrees C. The other GPU is running at about 42 degrees C, and the CPU is running at about 49 degrees C. So these are all very good temperatures. The feedback loop is not, I would have actually thought that the feedback loop would have given me a better temperature exchange, but essentially they run identical. So we're not losing anything. It's not like I'm screwing up the system by putting in the feedback loop. I've been able to now decouple the three pumps, the three water blocks, to run them independently without any loss of temperature performance. That's essentially what I'm showing here. Okay, so with that, that's my sort of introduction to, or sort of my explanation of what this feedback loop is and what I did with my water loop. And I'd like to basically throw a shout out to the water cooling subreddit, because it was really a big inspiration for me to sort of follow all the posts there and get a lot of, I posted questions about what to do with my build, and I got some great answers from the people who sort of followed that subreddit. So thank you guys over in the subreddit, water cooling subreddit, and I wish everybody well, and I hope that all your water cooling woes will go away. May all your builds be beautiful builds. And if anybody has any questions about this feedback thing, you can always post a comment. And in general, my sort of big takeaway is my system here is very, very over-engineered. It's hard to fill. It's being able to run each one of the GPUs on the sort of the water blocks independently, the pumps and the water flow through each GPU independently is fun. I think it's sort of extreme, I don't know, water cooling geekness to be able to do that. There's the benefits of running it like that are more of a gee whiz maybe than it is for sort of practicality. Don't spend so much time doing crazy stuff like this. Spend more time playing video games would be my suggestion. So, but I thought it was kind of a neat thing to stumble into this feedback loop phenomenon that I stumbled into, and I definitely wanted to share it with you guys in case maybe someone else might want to try it. Okay, thank you everybody for your attention, and Godspeed with your water loops.